Okay. The key formula we're going to learn is interest rate equation. Okay, the interest rate R equals real risk-free rate R star plus the four additional premiums, IP, DRP, LP, MRP. Inflation premium, default risk premium, liquidity premium, and maturity risk premium. Okay, and the corporate bond yield spread is the difference between corporate bond yield and treasury bond yield. And it equals to default risk premium plus liquidity premium. Okay, we will explain all of these in detail. All right, let's first go through some basic concepts about different interest rates. The first concept is very familiar, we should be very familiar with, is nominal rates. Okay, it is the interest rate before taking inflation into account. We say nominal rates are quoted rate, stated rate, or APR that are usually the interest rates we get from the financial institutions, right? Here we also say that this is the rate before we remove the inflation rate. Okay, it doesn't take inflation into account, so it includes the rate itself includes the inflation there. For example, if you borrow $100 at a 6% interest rate, you can expect to pay $6 in interest without taking inflation into account. It doesn't just adjust for the inflation rate. We say this because we're trying to compare nominal rate to real rate. Real rate is the interest rate that adjusts for the inflation and gives the real rate of a bond or a loan. Okay, so the real rate is the nominal rate minus inflation rate, or you can also call inflation rate inflation premium. Okay, so the corresponding nominal rate and the inflation rate are needed in order to calculate real rate. The real rate shows the interest rate lenders or investors are receiving after inflation is factored in. It gives them a better idea of the rate at which their purchasing power is increasing or decreasing. For example, if a bank loans a person $200,000 to purchase a house at a 3% rate, if the inflation rate is 2%, what is the real rate of this loan? Okay, so here the nominal rate should be 3%. The inflation rate is given 2%. We're asking for real rate. Okay, so we have to use the nominal rate minus inflation rate. So the real rate that we already take into inflation rate into account is 1%. Okay, you just use 3% minus 2%, so it is 1%. Okay, let me write this on the notes too. Okay, so I just typed in the equation here. Real rate in this question equals to nominal rate minus inflation rate. So it's 3 minus 2, which equals 1. Okay. Another concept we need to know is risk-free rate. Okay, it is the theoretical rate of return of an investment with zero risk. It represents the interest an investor would expect from an absolutely risk-free investment over a specified period of time. Okay, because in theory, risk-free rate is the minimum return an investor expects for any investment because he will not accept additional risk until the potential rate of return is greater than the risk-free rate. Okay, so we will discuss this more in the future. It is the higher return, higher risk principle. Okay, for investments that are of higher risk, investors usually require higher return to compensate them for undertaking the additional risk. Okay, so usually we say that when we see an investment target that is of no risk at all, it should have the lowest return, okay? And it is the minimum return that an investor is requiring for risk-free assets, okay? And for other risky assets, we would require higher return because we're taking more risk, okay? We usually consider the interest rate on a 3-month US Treasury bill as risk-free rate. Okay, we look at 3-month US Treasury bill. Okay, we think it almost has no risk. It almost has zero risk. So we say the rate of return for a 3-month Treasury bill is risk-free rate. Okay, so for any bonds that are of longer term or bonds that are issued by corporates rather than government, or for stocks, we say those other assets are riskier than this 3-month US Treasury bill, and the return for those riskier assets should be higher than this 3-month Treasury bill. Okay, we consider 3-month Treasury bill as a riskless asset, so we say the rate of return for it is risk-free rate. Question: is the risk-free rate nominal or real? Okay, remember nominal rate minus inflation rate is real rate. Okay, for nominal rates, it doesn't take out the inflation part, but for real rate, it does. Okay, which should we choose? Okay, it is actually nominal rate. Okay, any given rate usually is a nominal rate. News. Here's some additional reading here. Okay, it's kind of long. You can read it yourself. This news is about whether treasury bonds are risk-free. Okay, usually we say it's almost risk-free, especially for the short-term ones. Okay, they have very low free credit risk, and they may have interest rate risk or inflation risk. Okay, you can read this paragraph on your own. Some additional information in the news about the risk of a bond or of a treasury bill. Okay, let me go to the fourth type of concept here, which is real risk-free rate, R star. Okay, so we already know that risk-free rate is the rate of return for a riskless asset, such as 3-month treasury bill. Okay, and we know that it is nominal rate. Okay, if we use risk-free rates minus inflation rates, we will get the real risk-free rate. Okay, remember, nominal rate minus inflation rate is real rate. So nominal risk-free rate minus inflation is real risk-free rate. Okay, it assumes no risk or uncertainty, simply reflecting differences in timing, the preference to spend now or pay back later versus lend now or collect later. Okay, so it's similar to nominal risk-free rate, it's just we take out the inflation part. For example, if risk-free rate of return for, say, a 3-month treasury bill is 3% and the inflation rate is 2%, what is the real risk-free rate? So again, here we should do nominal risk-free rate as 3%, inflation rate as 2%. Take the difference of the two, the real risk-free rate should be 1%. Okay, risk-free rate is low in the first place. Therefore, real risk-free rate can sometimes be negative, particularly in times of high inflation. Okay, so if risk-free rate is 3%, and if the economy is bad and we really have a high inflation rate, such as 4%, then 3 minus 4 becomes -1. In those special cases, real risk-free rate could be negative. Okay, let me also add the equation for this example here. Okay, so I added the equation here about of the solution for this example. Okay, so far we've learned two groups of concepts. Okay, in the first part of chapter 7, class 1, we're comparing nominal rate to real rate. Okay, nominal rate minus inflation rate is real rate. Okay, and when we apply it to the special risk-free case, the nominal risk-free rate minus inflation rate equals real risk-free rate. Okay. Okay, so in the second part for interest rate, let me introduce some concept about risk premiums. Okay, and we're going to use these risk premiums to calculate the interest rates. Okay, each risk premium is added because the bond has additional risk. Remember, we start from risk-free asset. The rate of return for risk-free asset is risk-free rate. Okay, and when it has other premiums or other risks, we add to the real risk-free rate to calculate the interest rate. Okay, we'll show the process later, but let's just break down and look at the premiums first. Okay, the first premium is inflation premium. The currency's purchasing power is reduced by a rate known as the inflation rate. Inflation makes real dollars less valuable in the future and is factored into determining the nominal interest rate. The difference between nominal interest rate and inflation rate is real interest rate. Okay, this we have discussed, and we know that the nominal rate R minus the inflation premium IP equals real risk-free rate. Okay, so when we're calculating R, and if we start from R star, we will need to add this inflation premium or inflation rate to get R. Okay, so R equals R star plus IP. Okay, or here, as it shows, R minus IP equals R star. Okay, let's look at this graph here. It shows us the US inflation rate and nominal interest rates from 1960 to 2013. Okay, you can see the dark line, which is usually above the other gray lighter line, is nominal interest rate. Okay, the dark line is the nominal interest rate, and the gray line or the lower line usually is the inflation rate. Okay, in most cases, nominal rate is higher than inflation rate. Okay, so we know the gap of them is the real risk-free rate or real interest rate. Okay, and it is positive for most of the times. But in special times, such as financial crisis, for example, around 2008, you can see that the gray line is above the dark line. Okay, so the inflation is so high, it is higher than IP is higher than R. So the real interest rate, R star, becomes negative. Okay, the second premium is default risk premium. Okay, we have this premium because for some bonds, they have default risk. Okay, this is the risk of the bond going into default. What is the chance that the borrower won't make payments on time or will be unable to pay what is owed? This component will be high or low depending on the credit worthiness of the person or entity involved. Okay, usually we say that the default risk premium is very low for treasury bonds because they are backed by the government. Okay, and there's a lower chance of the bond going default. So DRP or default risk premium is lower for the treasury bond and higher for the corporate bonds. Okay, especially for those large, or small startup firms, there is a chance that they could go bankruptcy and they couldn't pay you the bond bond interest anymore. So we say, especially for those smaller risky firms, the default risk premium is higher for them. So we would add a higher DRP. Okay, for large mature firms, the DRP will be lower. And the DRP or default risk premium for treasury bond is the lowest. Okay, the next premium is liquidity risk premium. Okay, this is the risk the risk of not being able to sell the bond in the market and get cash. Okay, some investments are highly liquid, meaning they are easily exchanged for cash, such as U.S. Treasury debt, for example. Other securities are less liquid, and there may be a certain loss expected if it's an issue that trades infrequently. Holding other factors equal, a less liquid security must compensate the holder by offering a higher interest rate. Okay, question here, what is the most liquid asset? It is cash, okay? And the liquidity level or the liquidity risk of other assets depends on whether it's easy for you to trade those assets into cash. Okay, for example, for U.S. Treasury debt, because there are a lot of buyers and sellers in the market. So whenever you need to sell your Treasury bond that you hold into cash, it's very easy for you to find buyers. So we say that the liquidity risk for Treasury bond is very low. Okay, and we say that the Treasury bond is very liquid. It's easy to trade it for cash. However, for some other bonds, such as corporate bonds, especially again for those smaller firms that are not famous, there are not many people knowing about them, and there are less buyers or sellers in the market. So if you hold such bonds, whenever you are in urgent need of cash, it's hard for you to find a buyer and trade for cash. Okay, and you could have a discount in the price when you are selling. So such bonds, we say, has a higher liquidity risk because they're illiquid. So we require higher interest rate because of the risk we're bearing here. Okay, so we should add a liquidity risk premium when we calculate interest rates for such bonds with higher liquidity risk. So that's about liquidity risk premium. The next premium is maturity risk premium. All else being equal, the bond obligation will be more sensitive to interest rate fluctuations the longer to maturity it is. Okay, so the long-term bonds has higher maturity risk premium than short-term bonds. Okay, if the duration of the bond is longer, there is a higher risk that the interest rate would change to affect the price, okay, due to the market environment. So we say that for longer term bonds, there is a higher maturity risk. So the MRP, maturity risk premium, will be higher too. Okay, so here are the 4 risk premiums for bonds, and we treat these premiums as determinants of interest rates. Okay, and the interest rate R equals R star. Okay, we start from R star. R star is real risk-free rate. Okay, this is for risk-free assets. Okay, and if we add inflation premium IP, R star plus IP becomes risk-free rate, nominal risk-free rate for risk-free asset. Okay, and then after we add default risk premium, DRP, and liquidity risk premium, and the maturity risk premium, we will know the interest rate for the risky assets. Okay, and the premium we add depend on what kind of risk this risky asset has: default risk, liquidity risk, or maturity risk. The higher the risk, the higher the premiums, the higher the interest rates. Okay, so we're saying here risk-free rate, okay, nominal risk-free rate is real risk-free rate R star plus IP inflation premium, DRP, default risk premium, plus liquidity premium, LP, plus maturity risk premium, MRP. Okay, here is a graph showing us which type. So we have this comprehensive formula here to calculating interest rates for different bonds. Okay, then we have this graph here showing us which kind of premium exactly are we adding to each different type of bond. Okay, non-zero premiums for different types of bond. Okay, for inflation premium, we need to add this to all types of bond. Okay, so we say yes to inflation premium for all kinds of bonds. For maturity risk premium, again, it means that for bonds with a higher term, there's a higher maturity risk. So it only applies to long-term bonds. Okay, so we only say yes to maturity risk premium for long-term treasury bond and long-term corporate bond. Okay, no matter it's treasury bond or corporate bond, as long as it's long-term, it has maturity risk premium. But for short-term treasury bond or short-term corporate bond, no matter it's treasury or corporate, as long as short-term bond, we say it does not have maturity risk premium. And again, usually we consider bonds within 1 year as short-term, and we assume that maturity risk premium for bonds within 1 year is 0. Okay, for default risk premium and liquidity premium, remember their definition is whether there's a risk that the bond issuer will go in bankruptcy, so the bond goes default, or whether it's popular enough in the market or not, so we can exchange the bond into cash easily. Okay, depending on the liquidity level of the assets. So default risk premium and liquidity premium, they only apply to corporate bonds. Okay, only corporate bonds has default risk premium and liquidity premium. Okay, for treasury bond, no matter it's short-term treasury bill or long-term treasury bond, because it's backed by the government, usually we assume that it has 0 default risk premium. Okay, you don't have to worry about not getting your interest. And we assume it has 0 liquidity because usually these treasury bond, no matter it's short-term or long-term, they're very popular in the market. It's easy to find buyers to trade into cash. Okay, it's only the short-term corporate and long-term corporate. They have default risk premium and liquidity premium. Okay, so in our homework or exam questions, even though you have this the comprehensive formula on the formula sheet, that when you are calculating the interest rates for the bond, you will have to consider whether they have IP, DRP, LP, MRP. However, you need to determine which are the premiums you need for this type of bond. Okay, for example, for short-term treasury bond, to begin with, all types of a bond, they would start with real risk-free rate R star plus IP. Okay, all these 4 types of bond has the component of risk-free rate. Okay, and for short-term treasury, we say that the rate of return for short-term treasury is just risk-free rate. Okay, we consider it risk-free because we don't think it has we think it has no maturity risk premium, no default risk premium, or liquidity risk premium. Okay, so when we are calculating the rate of return or interest rate for short-term treasury, we only need to use real risk-free rate plus inflation premium. Okay, it still has inflation risk, but we don't add MRP, DRP, or LP. Okay. For long-term treasury, however, we need to add one more premium, which is maturity risk premium, because it's long-term. And because it's treasury, so it doesn't have default risk premium or liquidity premium. For short-term corporate, because it is short-term, so it doesn't have MRP. And because it is corporate, so it has DRP and LP. So when we are calculating interest rate R for short-term corporate, we use R star plus IP plus DRP plus LP. For long-term corporate, because it's long-term, so it has MRP. Because it's corporate, so it has DRP and LP. Okay, so for long-term corporate, we need to use all of the premiums. We use R star plus IP plus DRP plus LP plus MRP. Okay, you will look at this last comprehensive formula on the formula sheet in the exams, but you need to know when it's a treasury bond, then you don't have to use DRP or LP anymore. When it's a short-term bond, then you don't have to worry about MRP anymore. Okay, so all these premiums are also factors that are also representing the factors that affect the level of interest rates. The R star real risk-free rate, it actually represents production opportunities and time preferences for consumption. Okay, it tells us that we require a certain interest rate for the bond because we could otherwise use this money to invest in other production projects and make profits, or we could otherwise use the money to consume. So we require real risk-free rate for even riskless assets because we could use the money to do other things instead. It's an opportunity cost here. The default risk premium, liquidity premium, and maturity risk premium represents the other risk we have by purchasing the bond. Inflation premium stands for the expected inflation risk we have for purchasing the bond. Okay, so these are the factors we consider here using the equation to calculate the bond. Okay, so here is two groups of concepts about bond. We use nominal rate minus inflation to get real rate. We use nominal risk-free rate minus inflation to get real risk-free rate. Okay, and for calculating the interest rate of the bond R, we use the real risk-free rate R star plus 4 additional premiums: inflation premium for all bonds, DRP and LP for corporate bonds, MRP for long-term bonds only. Okay, another thing we want to discuss here is term structure. Okay, term structure is the relation between interest rates and maturities. Yield curve is the graph of the term structure. Okay, so if you draw the yield curve, okay, you will see that the X is maturities, the term of the bond, the maturity of the bond, and Y will be R, interest rate. Okay, it's the relation between R and T. R is Y on the graph, and T is the X is on the x-axis on the graph. Okay, and for short-term treasury, Again, interest rate is just real risk-free rate plus inflation premium. For long-term treasury, it is just real risk-free rate plus inflation premium plus MRP. Okay, for treasury bond, no matter it's short-term or bond, long-term, we do not have ERP or LP, but we do have MRP for long-term bonds. Okay, so as maturity becomes larger, MRP becomes larger, but inflation premium IP can be either larger or smaller. So interest rate can be larger or smaller. So yield curve can be upward sloping, flat, or downward sloping, depending on both IP and MRP. Okay, so let me try to explain this better. Okay, so if you look at the long-term treasury bond formula, R equals R star plus IP plus MRP. Okay, we know that for two assets, imagine you have two treasury assets of different maturity. Okay, they should start from the same R star, same real risk-free rate, same inflation premium. However, the bond with longer term should have a higher MRP. Okay. However, it also covers more years, so the inflation premium could be either larger or smaller. Okay, if IP and MRP are both larger, then R should be larger for this longer term bond. If IP becomes smaller though, and it's so small, so much smaller to offset the effect from the larger MRP, then R could be even smaller. Okay, so as T goes up, R can goes up, down, or not changed, depending on whether IP is increasing or decreasing. And if IP is decreasing, whether the degree of IP decreasing can offset the increase of MRP. Okay, so as a result, if we look at the yield curve, which shows the term structure for us, okay, again, the x-axis is years to maturity, T. Okay, the y-axis shows interest rate, R. As T goes up from 0 to 10-year, 20-year, 30-year, R can go down, go not changed, or go up. So the yield curve can be upward sloping, downward sloping, or not changed. Usually, in most cases, in good economy, yield curve is upward sloping like this one. Okay, and in bad economy, it could be downward sloping, and in between times, it could be flat. Okay, so an upward sloping curve is a typical yield curve. In good economies, we have increase in IP and increase in MRP when T increases. For longer term bonds, usually we have higher MRP, we also have higher IP. Okay, while the R star risk-free rate is not changed. So the interest rates should be higher for longer term bonds. All right, so this is a typical graph for yield curve. Now let's try to construct a yield curve. Step 1 is usually find average expected inflation rate over years 1 to n. Okay, so in order to construct yield curve, we need to calculate interest rate for bonds with different maturities. Okay, and remember R equals R star plus IP plus MRP for long-term bonds. So let's calculate IP and MRP and calculate R for bonds with different T. Okay, and let's first calculate IP. IP for bonds with n years is the inflation rate for year 1, year 2, until year n, added up together, divided by n. Okay, so the inflation premium is the average level of inflation rate over the n years. Okay, expected inflation over the next few years. Okay, so let's not look at the solutions now. Okay, please try to look at this example and solve for the average inflation rates as the inflation premium. Okay, assume inflation rate is expected to be 5% next year, 6% the following year, okay, and 8% thereafter. What is 1-year inflation premium, 10-year inflation premium, and 20-year inflation premium? Okay, I'm gonna try to end this video, and so you can pause. Please take out a pen and pencil and try to work on this question yourself before looking at the answers. Okay, since we know that the inflation rate is 5% for the first year, 6% for the second year, 8% from the third year, and for all the other years afterwards. Please try to calculate the average inflation rate for the first year, 10-year, and 20-year as the 1-year inflation premium, 10-year inflation premium, and 20-year inflation premium. Okay, I will pause or end this video, and I will talk about the solution in our next video.